Welcome to AI in Plainsight, the computer vision podcast, where we chat with the Vision AI pros to discuss the latest use cases, nerd out on potential new applications, and expand our own understanding of the potential for computer vision in production. I'm Paul Davenport, Plainsight's Director of Communications, and joining me as co-host is Bennett Glace, Plainsight's Content Marketing Manager. How's it going, Bennett?
It's going great, Paul. Happy to be here.
Awesome. All right. So today we've invited Logan Spears, Plainsight's co-founder and CTO, to join us in a conversation on one of the hottest topics in tech this year, AI-generated imagery, with solutions like DALL-E 2 and Midjourney composing impressive scenes that have won awards and attracted no shortage of controversy. Logan joined us to discuss the data science behind popular solutions, a few remaining limitations and challenges, and some of the big questions posed by the rise of AI-generated artwork. Enjoy the show. Logan, welcome to the show.
Yeah, welcome, Logan.
Hey, happy to be here.
So Logan, off mic, you mentioned that DALL-E 2 is one subject that tends to come up in a lot of casual conversation. I think you said it's the one thing that tends to come up the most at dinner parties. What sort of questions do people tend to ask about it?
Well, I think the initial reaction is, how does that work, right? It's not something that people expect AI to be able to do today, but they're seeing it in reality, right? So I think people have accepted that AI will beat them at chess, kind of do some of the automation work and detect, let's say, the number of people in an image or something like that. But I don't think people were ready this early for it to be more creative than they are. I think that caught people off guard, and I think there's been a significant wow factor.
Yeah, so it was very much something that we understand AI as a practical tool, but not one that maybe competes with our own imaginations. Is that maybe something that you're intuiting with folks?
Yeah, I think so. I think that's why it's captured the public imagination and caught people off guard.
Awesome. All right. So we've obviously seen some example of DALL-E 2's work, but what exactly is going on there? So how does this technology work? Could you unpack that a little bit for us in detail?
Sure. Yeah, it's easiest to conceptually break it up into a couple different parts. So you're taking a text prompt, a corgi playing a trumpet, and generating an image from that. And there's kind of a couple steps in between. First is to understand what a corgi playing a trumpet means semantically, not just, the words in a specific order. There's been a lot of development in the NLP space, and I like to think of the massive developments as really a couple of tricks for massive scale, what's called semi-supervised learning. So one in the NLP space is you take a sentence or a paragraph and you try to predict the next word or a blanked out word within that paragraph. So that requires a semantic context to be able to do that. And you can do that on the scale of the entire internet. Think of all of Wikipedia, for example. And if you do that enough, you will gain language understanding. So, you can create a large model, let that run, and eventually you'll get high fidelity language understanding on a semantic level. So that's the part one, right? Kind of understanding what's in that text. Step two is matching that to what's in an image. So being able to go from really reversing the problem from an image to text, like image captioning, describing what's in an image. So you can see that with models like OpenAI's Clip, where they're using also scouring the internet, but using text and image pairs. So you think of Google Photos or image search, where you have a text description, either a caption. You see this in news articles, for example, where they'll say, hey, person on the left doing X, Y, and Z, that kind of thing. If you scour the internet for enough of that data, you can build a data set and predict the text from an image. So that kind of bridges that language and vision divide, where you can create what's called shared embeddings that are essentially neurons in a neural network that have a shared understanding of what a concept actually is across modality. So then what DALL-E 2 did, in addition to that, is use a diffusion model technique where they actually start from noise and work backwards to generate an image. And to train this, you also reverse the problem. So they took a lot of images and then gradually added noise to them, and then trained it going the other way to predict going the other way. So if you kind of stack all that together, you have a text prompt, you start with noise, and you can generate an image that shares that semantic similarity with the text prompt. So you get a picture of a corgi playing the trumpet, for example. And you get a couple of them because you can start from noise. You can kind of generate, let's say, 5 or 6 examples, and the user can select which ones they like. So kind of at a conceptual level, that's how DALL-E 2 works.
So in the US and several countries around the world, patent law has held that AI can't be credited with an invention. So that seems to suggest that in the eyes of the law, at least, AI is incapable of creativity or truly independent thought. I'm wondering where you land on this issue, and if you think what DALL-E 2 does is an example of creativity, or how it compares to true creativity.
One of the relevant examples in this space from a legal precedent is the Supreme Court case in 2006. I think it was Google Books, or Google and their Books Initiative versus the Authors Guild, where the Supreme Court ruled that derivative use of copyrighted works was fair use, and it was legal for Google Books to extract copyrighted material and build things like AI models, etc., from that derivative use. So that's kind of the most interesting precedent in the legal space, at least, for AI use. And that's how things like DALL-E, for example, are able to scrape the internet, and it's kind of legal, right? And we can see that as kind of a shared consciousness, and that kind of makes sense intuitively that I think that's all within fair use. As far as kind of the attribution of those models, to me, and I've been on a couple patents, it kind of seems like a just bureaucratic issue, right? Where they have to list inventors. And even if those are assigned to companies, and companies own that patent. So to me, it seems kind of an intellectual property issue more so than precedent on who's really the creator. And obviously, government, the bureaucracy is not ready for AIs being people today. We hear about corporations or people.
Corporations, yes, but AI,
yeah, and
no,
that's kind of a legal simplification, right? I don't think the government's ready for AI. Neural networks are people yet today.
Yeah, no, I think that's super interesting too. And you also hit on the point that, yeah, it's not so much a philosophical question when it goes into the legal realm. It's very much just, okay, there needs to be accountability and ownership here. And we're not great about agreeing on things like that. So that makes a ton of sense. I guess another question that builds off of that is, where is AI-generated art already seen today? Beyond the DALL-E 2s, is it in other kind of scenarios, like out in production in the world?
I mean, you're already seeing people use these models for actual production use cases. So one of the first areas that I saw it was YouTube thumbnails. Just creators who got an invite to DALL-E 2 and the OpenAI beta started using it as their thumbnails because they could generate more creative works faster than they could, either using stock footagery and editing that, or having an artist go through and create something novel, right? Which has a significant time delay that is not measured in seconds, which AI generated art is. There's kind of a realm of use cases where it might already be more expedient to use the AI generated art. You can think of a video game 2D assets. They have to generate tons and tons of assets for certain video games. Think of like GTA 5, for example, or even like Magic the Gathering, the person or avatar character or card design, those kind of things where, you have situations in certain companies that have to generate a vast amount of unique art, and doing that where margins might matter. And that's where the AI generated art is particularly interesting.
Gotcha. So Expediency and scale are really kind of the big benefits I pulled out when we're
Exactly.
working with AI generated art. That said, should artists themselves be worried, in your opinion?
Well, I think what we've seen over the past couple hundred years is everybody should be worried eventually, no matter what profession they're in. The professions and jobs are constantly being supplanted by technology, and people are having to be retrained and adapt to the new world order. That being said, I think some of the first areas that might be in trouble are things like stock imagery, for example, that has they have to acquire content from photographers or things like that. That's one area where it could be cannibalized. And then, yeah, some kind of creative tasks, maybe logo generation, something that's simplified or kind of a well-defined problem, like generating iOS app icons or something. If that's your job, that's something I could see being automated pretty quickly, and people might prefer that with full control, the speed, and not the additional cost of human in the loop. So there definitely is areas that I think are vulnerable to this technology.
Are there specific types of imagery that have been especially challenging for DALL-E 2 and similar solutions so far? And if so, why these types of images?
Yeah, so if you think of what's challenging for the AIs and DALL-E 2 specifically today, it's things that aren't represented well on the internet. There's a systemic bias of what's training these things, and that's what people take pictures of and put on the internet. And that includes creative works as well, historical paintings that have been scanned and put on the internet as well. Obviously DALL-E 2 has the ability to fill in the gaps, right? Because it has that conceptual understanding and mapping of the text to the image. It can kind of generate novel images like a corgi playing a trumpet, even if that doesn't exist. But it has to know what a corgi is. It has to know what a trumpet is to be able to do that. And that's just an example of that. At Plainsight, we see a lot of examples of data that is not on the internet. Let's say QA for manufacturing, where the camera is looking at a manufacturing line all day. They can't go use images from DALL-E 2 to simulate their assembly line today. It's unique to them. It's not represented on the internet. And DALL-E has no priors to kind of generate something close, right? It could maybe generate microchips on a factory floor or something like that from an image, but they won't be specific to the customer and what they care about, right? So I think that's the current limits of this technology. And it also can get confused on something that can seem obvious to human. Things like eyes tend to be a problem, where we have hardwired, from even infants can, detect the pattern of the face and what eyes should look like and things like that. Some of those humans, notice quickly when the DALL-E will make a mistake in that. So there is some kind of human advantage in certain features that are kind of ingrained in our biology.
Yeah, that's always been kind of my uncanny valley take whenever I've seen like so-and-so celebrity doing something in space. I'm like, okay, the space stuff actually looks right.
Yeah.
It's the person in the face that I'm very, very lost with. So that makes a ton of sense. Yeah.
And that's the kind of spooky factor to it for sure is it doesn't understand us completely. We're just another object to it or something like that. Mm-hmm. So there's still a difference between the machine, the man and the machine, if you will. Well, and one other contributing factor is they blacklisted like essentially proper nouns. So like specific people, it's too politically charged, there's ethical issues there. And they chose to restrict the model from doing that. So it doesn't know Barack Obama, for example. Now there's other non-DALL-E 2 models that, I think chose to not do that, right? But that's some of the contributing factor as well, is it has to be generic people, not specific people, and that reduces in scope their training data for that kind of thing.
So no Nick Cage riding a corgi playing a trumpet.
Not for DALL-E 2, at least. This technology will get there.
So, on the more philosophical side of things pertaining to AI and whether or not it can be truly creative, would you characterize AI supported research as creative in its ability to sort of reach novel conclusions or detect what people might have missed?
Yeah, I mean, I think creativity is, the application of human potential to problems in novel ways that are not just completely linear, kind of connecting the dots. And AI research is accomplishing some of the most interesting new developments in humanity right now, in my opinion. Like, I think there's going to be Nobel Prizes on some of these novel model architectures and developments. So I would definitely categorize the research side as creativity. I think another interesting segue there is, are the models themselves creative? Is AI creative? And that's kind of a more interesting question, where they're doing basically a deterministic process through kind of what can be characterized in equations, right? So is that creativity? I think I'll probably leave that to the viewer, but it's not in the same way. We share some biological similarity to how these models are architected. We've all heard the term neural networks. This structure is biologically inspired. These models are biologically inspired. They share our method of, using sensory input and generating mappings in more and more semantic detail and kind of specificity, and being able to kind of regurgitate that through other modalities like language, like I'm speaking now, right? Even though there's that kind of biological similarity in the structure, one's deterministic, well, you can argue whether the universe is deterministic, right, as well. And, it has its laws of physics that underlie it, whereas the neural networks have kind of the math that it's taken to generate those results. So I would probably say models aren't creative. I think they're just processes. Like, I can run them on my computer, but they definitely generate the equivalent of what a human would be credited with creativity for. So it's difficult to say.
In this larger conversation too, we kind of allude to that human in the loop, which is something that in any computer vision model is definitely necessary if it's going to be for a production setting or something that's constantly improving in a less novel application like this, where the whole point is that we want to see something silly or see something beautiful or see something that our senses react to. Whereas when it's in a place where we need humans to actually inform what that biological replication a neural network is trying to execute on, it's a lot more important that there's a person there, because there are limitations on the capabilities. Does that kind of pass muster?
Yeah, I mean, you don't want. So if you just train DALL-E 2 on the internet, it'll hit 4chan, it'll hit Reddit, it'll probably, have a ton of racist content in it, for example. You can't let these things run wild. They need guardrails, and they need, kind of oversight with humans in the loop, predefining those ethical constraints. So definitely humans have to be in the loop. You see that in self-driving cars as well, where, what do you do when the car's speeding and it's kind of a decision between saving the driver and saving the pedestrian, right? Or, is there a calculation where it can kind of mitigate both? Those kind of things have to be overset by human. We can't just trust. Machine learning models don't have ethics. They don't have feelings yet. So humans need to fill that role.
Makes sense. And I think it's funny. With the example that you used too, it very much brought it to a material scenario. The driver versus the pedestrian is well beyond the philosophical kind of guardrails I was hoping to put on this, but a great example that applies here. All right. Thank you so much for joining us, Logan. Hope to have you back again soon.
Hey, thanks for having me.
Awesome. And thank you, listeners, for coming along for our latest episode. Stay tuned for more conversations with the AI pros around what the future looks like for computer vision in production here on AI in Plain Sight.